Okay, let's get started. Thank you for all of our live attendees for joining us today for our webinar, Going Serverless with Cubeless and Google Container Engine. I am your host, Mavian Ruiz, Bitnami's Partner Marketing Manager. Today we have Sebastian Goesquin, who's going to be the main star of the show, telling you all about serverless on GKE. Just as a high-level agenda, we'll go over who is Bitnami, what is Kubernetes, the benefits of Kubernetes on Google Container Engine, what is serverless, and an introduction to Cubeless, one of Bitnami's Kubernetes-native contributions and tools. After, we'll have a demo on how to go serverless in Google Container Engine, and then we'll have a live Q&A with Sebastian. So feel free to use the WebEx chat window, and I'll moderate those at the end. With that, I'm going to go ahead and let Sebastian take it away.
Okay, great. Thank you, Maven. Good afternoon, everyone. Good morning, good evening. I don't know where you are. You may be in Europe, in the US, in Asia, even though it's a little bit late. But hello, everyone. Pleasure to be here and give you this webinar. We're going to talk Kubernetes, specifically Kubernetes on Google Container Engine, on GKE. And then we're going to talk serverless in general a little bit. And then I'm going to introduce you Cubeless, which is a serverless solution that we're developing at Bitnami. It's an open source solution that everybody can participate in. Okay, so Mavian gave you the agenda, and we're gonna go straight up. I prepared some slides, of course, and then I also prepared quite a few demos. Hopefully, they should all run very well. It's very well rehearsed. We'll see. It's been rehearsed as of 2 hours ago. So who is Bitnami? Who are we? You may know Bitnami because we package a lot of open source applications, and we make those open source applications available on public clouds. So Google, of course, and we're going to talk about GKE today. But if you go to the Google Cloud Launcher, if you go to the AWS Marketplace, even Microsoft Azure and so on, in all those marketplaces, you see some applications from Bitnami, and you're probably deploying applications from Bitnami. We track over 150 open source applications. We have something that we actually call the tracker. We track those apps, we detect when there are new versions, when there are new patches, and so on. And then we have an internal build pipeline to dynamically download all the source, the patches, recompile everything, package those apps in the correct format, and then push them to the cloud providers or build the artifacts in very specific formats. So that's what we do at Bitnami, and we're quite successful at it. Here is an example. If you go to the Google Cloud Launcher, so this is not container-based right now. This is not Kubernetes specific. It's just regular cloud usage. Here we're talking about virtual machines that contain those open source applications and are available directly from the cloud providers. So here you see the Google Cloud Platform, Cloud Launcher, and then if you search for Bitnami, you see 124 applications, Node.js. I mean, those are the first ones that showed up in my search. Okay, so that's what we do, and we do it extremely well and often. And of course, we build containers, and today we're going to talk about containers. So, that's where Bitnami starts becoming extremely interesting in this new space, is because we track all those applications, we build VMs, we publish to the cloud, but we can also build containers with exactly the same system. We can package the applications as containers, okay? So, of course, some applications that don't really make sense as containers because they may have lots of different processes and so on. But we have lots of containers on Docker Hub that are available. And then, we routinely build them when there are new versions and so on. Okay. So for example, that's something that came up today as I was preparing for the talk. There was a new Joomla release. Joomla being one of the CMS out there. There was a new Joomla release, 3.7.4. It was released 20 hours ago. So right now it's been released 24 hours ago. By the time I wrote the slide, it was 20 hours ago. Within 4 hours, the Bitnami Docker container for Joomla was published. And here you see the snapshot of our GitHub page for our Docker Joomla container, and you see we have this 3.7.4.r0 release that was pushed 16 hours ago. So it took us 4 hours to detect that change, download all the code, repackage it, trigger an automated build via Circle CI. We have a bot that runs, and does all of this. So even the pull request that triggers the build is being done automatically. So we published that container in 4 hours. By contrast, the official Django image on the Docker Hub was updated 15 hours later. Okay, so we are faster than the official Django image on Docker Hub. It's not to say that our image is better, okay? We use our own packages, we have our own pipeline and so on, but it just gives you an idea of the strength of the pipeline that Bitnami has to build all those applications. Now, our strength is in the packaging, and Bitnami started as local installers on desktops, and then we started working on virtual machines. And of course the cloud. I showed you the cloud launcher, and then I just gave you an example of containers. So we package for the cloud, we package locally, we package for containers, and of course now we're seeing that there is this paradigm that's coming, where people are starting to build application with a serverless mindset. And later on I'm going to explain and to dive a little bit deeper into what that means. But for us at Bitnami, it's still an application. Okay, what we're talking about is still an application. It's going to be a distributed application where the different parts are built from containers, and it's probably going to be an app that's managed by Kubernetes. But at the end of the day, it's still going to be an application for us. And since our strength is in packaging, we want to make sure that we address the future landscape of serverless. Okay, because we see this evolution in terms of packaging application from local installs, virtual machine, cloud, containers, and then functions. Okay, of course, those stages of packaging are at different maturity level. Okay, so we're well aware of this. The maturity of cloud apps or container-based apps or functions are totally different. But we need, as a company, to be able to provide our customers with those different packaging. Okay. So now in that picture that I showed you, I talked about containers as a new packaging format. But the truth is that the way we're going to operate containerized application is thanks to Kubernetes. Over the last, let's say, 2 years, Kubernetes has emerged as the de facto standard for managing distributed applications built from containers. Okay, it's still an area that's evolving. There are things that change and so on, but really, if you look at the last year, Kubernetes has really grown in strength and has really taken a hugely dominant place in managing containerized application. So what is Kubernetes? It's Greek. It means at the helm of the ship. It's piloting the ship that has all the containers and that is moving the containers. That's the metaphor. So here you go, Greek term. And then, from the website, it's simply an open source system for automating deployment, scaling, management of containerized applications. So for me, Kubernetes is a system that manages distributed application in the data center. It's open source. It's available on GitHub. It's based on 15 years of container expertise at Google. There is an extremely rich core API, so that's one of the strengths of the system. And then it's featured with tons of amazing things. And I just listed a few of them here: cluster federation, role-based access control, quotas, network policies, and there are more. But just those, what is that, four? Just those four features, when you look at them, what strikes me is that in previous big systems, maybe OpenStack or CloudStack or other large system, some of those features tended to be commercial add-ons. Okay, so you were buying, you were starting to use the open source solution, and then if you wanted to have quotas enabled or billing or network, some stronger network isolation, you needed to buy a commercial add-on. And that's not the case with Kubernetes. When you get Kubernetes out of the box, you get role-based access control now, since 1.6, let's say 1.6 the version. You have quotas from the beginning. You have network policies, assuming you use a network add-on that has a network policy controller. I'm starting to throw some terms here, but it's available. And then you have something which is going to be extremely powerful in the coming year and coming years. It's cluster federation. That's the idea that you can have a Kubernetes cluster on-prem, you can have a Kubernetes cluster in the cloud, you can use a Kubernetes cluster like GKE, maybe, and then build a federation between all those containers, all those clusters. The strength of that idea is that you can move workload between data centers. Okay, that's really what's behind it, in addition of having a more fault-tolerant application. And of course, Kubernetes is the fastest growing project on GitHub. You can always argue about different measures of measuring health of community, but really the community is extremely strong in terms of commit, in terms of PRs, in terms of issues being filed. It's an extremely strong and fast-paced community. The key for me, why did I start learning Kubernetes and then teaching Kubernetes? I do a lot of training on Kubernetes. I've written the Linux Foundation course for Kubernetes. I do a lot of training with O'Reilly, Bitnami. We do a lot of training, But I was really inspired. That's the case by what Google has done with Borg. Okay, so Kubernetes is a system that's inspired by the internal tool used by Google engineers to manage their applications. So things like Gmail, YouTube, Google Compute Engine, all those applications that you use from Google, they are distributed applications. Okay, of course, they are not single server application, even just for fault tolerance, but scale and so on. They are distributed applications, and they're managed by Borg. Okay, and it's a system that used to be a secret for a long time, but then in 2015 they finally published a paper, and this is a snapshot of the paper. You can get the PDF. It explains Borg, and it explains the lessons learned that they've put into the design of Kubernetes. So Kubernetes is really a rewrite in the open of Borg, and that makes it extremely powerful. I'm not going to compare with things like Docker Swarm and Mesos and things like this. I do it a lot, and I know that people ask that question a lot. They want a comparison, and I always tend to give the same answer. For me, you have to put those to the test. You have to put those solutions to the test. You have to try them and see if they're a good fit for you, and see also if your staff has the expertise to be able to manage them. Okay. For me, I tried Docker Swarm. I knew Mesos from before, and then when I tried Kubernetes, for me it was a no-brainer. I liked the robustness of the system. I liked that it was very difficult to kill. It was a pleasure to work with, and I really liked the API. Okay. So that's Kubernetes. But Kubernetes is not just Google. Okay, Kubernetes was given to the Cloud Native Computing Foundation, CNCF, And there is a very strong ecosystem that has started to being developed there at CNCF. So you see on the left on that slide, you have Kubernetes, but then you have other projects like Prometheus for monitoring, Open Tracing for distributed tracing, even though that project is I wouldn't qualify as mature yet. It needs still a lot of work. gRPC is a protocol, FluentD for logging, Containerd, that's at the heart of the Docker engine. Rocket is another container engine. CNI is a solution for configuring networks for containers. So you have this foundation that has now been created to deal with managing those type of new applications and building those new types of infrastructure plumbing. And Kubernetes has kind of pioneered this movement, and now there are lots of additional software being part of CNCF. There is a very strong ecosystem that's being created. And in addition to those projects, you also have tons of companies that have joined CNCF. So of course, Google, Oracle even recently announced that they were joining CNCF. Red Hat, who is the second biggest contributor to Kubernetes. And then Bitnami, we are also part of CNCF, and we contribute to various open source solutions in the ecosystem, like Helm and the charts, like Cubeless that we're doing now. I was involved. I created Compose with a K very early on when I was running Skipbox. So we are involved in lots of different areas in the ecosystem and contributing to the growth of this ecosystem. Because without a strong ecosystem, you're not going to have a good solution for the long term. I hope that makes sense. I know I talk a lot, and there's very little feedback when we do those webinars, but I hope that that makes sense. Okay. We'll see how I get questions later on. Now, Kubernetes is a big system, but people tend to be quite impressed by the system. And usually, I have to say it comes from developers that have a single machine mindset, a single node mindset. Maybe they're not used to distributed systems. Maybe they haven't had experience managing, data centers or managing large clusters of machines. So it's important to demystify Kubernetes and its high-level architecture. So that's what this slide does. It's stolen from GitHub. You see the Google guys. I have no shame about it. It's a nice picture. So what do you see? The wheels in red, that's your head node. Okay, the heart of the head node is the API server. That's what we talk to. So the users, we talk to the API servers. Even the operators, they talk to the API servers. When we talk to the API servers, we make certain requests. Those requests, they need to be scheduled on all the nodes that form the cluster. So you see another red wheel, which is a scheduler. And then, I said the heart is the API server, but the real smart of Kubernetes is the controller manager. So you see another red wheel, it's the controller manager. And the controller manager is basically a control loop that runs all the time and that does everything it has to do or triggers all the actions that are needed to converge the desired state of the cluster with the observed state. Okay? So the system continuously monitors the state of the cluster, what's running in the system, and then it compares that state with the desired state that the users have declared. It's a declarative system, so the users declare, hey, I want the cluster to be in this state. And now the controller manager goes through all its control loop, triggers a bunch of actions, and then it gets to the desired state. Okay? The state of that cluster that I mentioned needs to be stored somewhere. So in traditional mechanisms, it would be a relational database, but now we need something that's resilient, that's distributed. So we have a key value store here at the top, which is etcd. It's a distributed key value store coming from CoreOS. That's your head node. It's quite simple. And a lot of systems run like this. Now on the nodes, you have the green wheels on the right, and the green wheels, what do you need on those green wheels? You need an agent. That agent is called the kubelet. That's the main Kubernetes agent that you need to install on all the nodes. That kubelet will receive the actions from the API server, or will talk to the API server, and then we'll talk to the local Docker engine to start containers. There is another thing, which is the kube proxy, which is a very important part of the system, which manages IP tables so that all the networking is in place. We're not going to go into networking, okay? Now, yeah, I decided to take some time to introduce Kubernetes in this webinar because, sometimes we forget about the basics, and then some people join the webinar and then they have even never heard about Kubernetes. So I like to spend some time explaining the system a little bit. So now, how do you get your hands on Kubernetes? First, there's something called Minikube, Mini Kubernetes. It's a single machine, standalone virtual machines that basically gives you a fully functioning Kubernetes system. Okay? You download the Minikube binary from GitHub and you'll get the slides, so you'll get the link. You download Minikube binary. Hopefully you have VirtualBox. If you don't have VirtualBox, you install VirtualBox. And then you type Minikube start. This will create a virtual machine on your laptop. In that virtual machine, we'll start all the smarts to get that API server, that scheduler, that controller manager, that kubelet going, okay? Except that instead of being a distributed system, all of those bits, they're going to start through a single binary, and they're going to run on only one virtual machine in your laptop. Minikube is perfect for learning, discovering, developing, okay? And I always say it, never think about using Minikube in production. I know some people have asked me the question, this is not meant to be a production system. This is for learning, developing. If you want to go toward production and you want to bootstrap your own cluster, whether bare metal or in the cloud, you can use a tool developed by the community upstream, which is called KubeADM, KubeAdmin, KubeAdam, whatever you want to call it, KubeADM. Okay? This is going to behave a lot like Docker Swarm. You're going to have your head node, you install KubeADM, you run KubeADM init. There's lots of smart in that command. It's going to install the API server, the etcd, the scheduler, and so on. At the end of the command, it will give you a secret token. You use that token, you go to the other nodes in your cluster, and then you run kubeadm join. Oops, I made a typo there. Forgot an E. You run kubeadm join -- token equals bang. And then what's going to happen is that those nodes, they're going to talk to your head node, and they're going to bootstrap the cluster. Okay? At the end, you're going to have a fully functioning Kubernetes cluster, and you need to configure your network. Okay? So it's 5 minutes more. I do this demo all the time, and I swear to you, in 5 minutes with kubeadm, I can bootstrap a Kubernetes cluster on DigitalOcean, okay? Or on AWS or Google, of course, okay? Start some VMs, SSH into the VMs, install the packages, run kubeadm, you're done. And then, of course, there's GKE. You know, this webinar is about GKE. So why is GKE interesting? Because GKE is a managed service for Kubernetes. You don't have to do that bootstrapping step that I just mentioned. Okay, you just say gcloud container clusters create name of your cluster. Here I call the cluster foobar. So this single line, sentence-based, that's why you love gcloud, it's going to create a Kubernetes cluster for you. By default, it will be 3 nodes. Okay. What Google does is that they actually manage your head node. They manage your etcd. That's the part of the managed service. They manage the head node and the etcd. And then for the nodes of the cluster, those are regular GKE instances that then have that kubelet agent running and so on. Okay. So excuse me. So you don't have to do the bootstrapping with kubeadm. You can just use the gcloud CLI, and you're up and running. If you've never used the Google Cloud, G-Cloud is just the command line interface that you install on your machine and with which you can talk to all the Google services. Okay? A nice Python CLI. Why would you use Kubernetes on GKE? Because it's a managed service. You don't have to worry about the Kubernetes master going down. You don't have to learn about the key value store or back it up. You don't have to worry about the networking. I don't worry about which container add-on to use and so on. And then they have, an upgrade process where they upgrade the head node and then you upgrade the worker nodes. Okay. And of course, it integrates very well with all other Google Cloud services like Hipster, the logging, and so on. Okay, so lots of good reasons to use GKE. I don't know if I'll do the demo. Maybe okay. Let's run the demo because that way it's not really a demo, but so you should see my screen, and I'm going to type G Cloud container clusters. Oops, not cluster. I forgot an F. Clusters list. Let me make that bigger. And you see here, so I asked the system, hey, give me the clusters that I have in the system. And now I'm going to create one. I'm going to launch that and go back to the slides. G-Cloud container clusters create, no, webinar I did. Let's create foobar. So here I have my default project set up with my CLI. I have my default zone, which is Europe, because I'm in Europe. And then now it's talking to the GKE service, and it's going to provision the instances, and I'm going to have a worker node after that. A worker node, a Kubernetes cluster, sorry. Now, that's all the introduction about Kubernetes. And we could go on and on. I have tons of great things to say about Kubernetes. And Kube, K8S. Why do we say K8S? Because in Kubernetes, between the K and the S, there is 8 letters. So K8S or Kube, it's the perfect platform to build systems on. All the core primitives are available and the system is extendable. It's a totally made-up quote from 4 hours ago. So I just wrote it. And that's really what I think, is that as soon as you start using Kubernetes, you realize that, of course, you can run, you can run Nginx, and then you can run Redis, and then you can start building your application and run Cassandra and things like this. But it's also a great platform to build your own systems. Okay, not already existing applications, but to start building a system that you really want. Why? Because the core primitives that you have in Kubernetes allow you to do everything. Okay, you have concept of service, you have concept of deployments, of replicas, things like this. Plus, Kubernetes has a very neat thing, which is that you can extend the API server. So that's a little bit mind-boggling when you start talking about Kubernetes and learning about Kubernetes. But the API server is dynamically extendable. Okay, that means that if in your enterprise you need a distributed system to manage databases or translators, whatever a translator is, you can extend the Kubernetes API. You can write a definition for what a translator is, and then suddenly Kubernetes is going to become aware of a translator object. Okay, and suddenly you use the Kubernetes client kubectl, and then with the Kubernetes client you can create translators, you can delete translators, you can modify them and things like this. Okay. So the system is very extendable, and that's super, super powerful. Which brings us to Cubeless. Okay, what is Cubeless? It's a Kubernetes-native serverless solution. What does that mean? It means that we built a serverless solution on top of Kubernetes by using the core primitives of Kubernetes and extending the Kubernetes API. Okay? Because it made total sense to us to build that system on top of it. instead of going, over there on the left corner, whatever, and then writing a system from scratch, which was not aware of Kubernetes, we actually started building a system which was Kubernetes-native or cloud-native if you want, okay? Maybe we should rephrase this as a cloud-native serverless solution, okay? And then we would get into CNCF. But that's what Cubeless is, okay? It's a Kubernetes-native serverless solution. It's open source. It's available on GitHub. You go to CPS, github.com/kubeless/kubeless. We intentionally didn't make it Bitnami specific, so it's non-affiliated. We have the Cubeless organization, and then anybody can, help us with this project. Okay? So let's dive deeper. And remember what I said at the beginning is that, for us, we see applications evolving in the way that they're being packaged. So the applications are packaged as VM. We support VMs. Applications are packaged as containers. We support containers. We are the leading contributors and maintainers of charts, which are Kubernetes packages. So we are experts in Kubernetes packages. But we see people starting to build applications with a serverless mindset. So we want to make sure that we can, accompany, is that English? Accompany people when they start moving to serverless. Okay, that's why we're doing this. Now, what is serverless? So that's a slide I've used before. There is no serverless. There is a server. Okay, let's stop this silly discussion. There is a server. Okay. There are some guys that managed to do computing while the bits were transferring into the network. I think it happens. You can do this with like some optical transformation, things like this. But that's not the case here. Okay, there is a server. Okay, because at the end of the day, you have a process executing on a server. So here the sentence says, there is no serverless. It's just someone else's fully managed execution environment that I only pay a fraction of a cent for whenever my function is run. And that's really what serverless gives you. It allows you to write small logical units, and deploy those logical units, business logic, deploy them in an environment that's managed by another system. In our case, it's an environment that's managed by Cubeless, which is an extension of Kubernetes. Why does it make sense? To me, it makes sense because when we talk about apps are going to evolve, and they're going to become a composition of multiple services, whether those are public cloud provider services or they're your own services, whether those services are legacy or whether they're distributed, it doesn't matter. But apps are going to be a composition of multiple services, and you need to knit those services together. It's the traditional approach of microservices or SOA or whatever, except that now with serverless, we have this system to write that knitting system, or to put that glue, if you prefer the metaphor of gluing services together. Okay, serverless is about writing the glue to connect all those services. And that's what Lambda does. So AWS Lambda is currently the leading serverless solution or serverless provider out there. And when you look at the examples that they have on their page, aws.amazon.com/lambda, you see things like, okay, I'm dropping a picture into a bucket, and then that triggers an event which runs my function and resizes the images. Or maybe I have some streams. When data arrives on that stream, it triggers my function, which sticks the data inside DynamoDB, and then I can do some analysis. So even when you looked at the examples from Lambda, they're about building more advanced application pipelines that are made of other services, DynamoDB, Kinesis, S3, you name it, okay? And you're trying to glue those services together, knit them together with simple, simple logic, okay? So, in that sense, serverless, it's also function as a service, and I don't want to get in the debate of naming because I think it's pointless. Where I put this is somewhere on the platform as a service spectrum. So you look at the PaaS, what is a PaaS, whatever. Again, let's not fight about names, but there are different ways to deploy applications, okay? And that's PaaS. But in our case with serverless, I also write here the term serviceful. This term was coined by Patrick Debois, the father of DevOps here in Europe. Really, really good guy. And he mentioned serviceful in a talk at the config management camp in Ghent in when was that, January. This is not going to stick, but I think it's more what it's about. It's actually about building application in an environment that's full of services. So it's serviceful instead of being serverless. But anyway, what we're talking about here is like a way to deploy apps somewhere in the PaaS spectrum. You don't push code like Git push, which is more like the traditional PaaS, like Heroku or even OpenShift or things like this. You're not running fully baked containers, meaning that your app is not built into a container, or you don't build the containers, okay? And then the infrastructure is totally transparent. It scales, you don't know how. The networking is in place, you don't care how, okay? And then you have a fine-grained cost management when you call the function. Those are some of the features of what serverless is. And it definitely relates to the problem of how fast can you go from source to production or from source to deployment. So I called it, MTTP, reduce the MTTP, the mean time to production, or reduce the MTTD, the mean time to deployment, as a joke compared to the MTTR. But that's the idea. So to me, it's somewhere in the PaaS spectrum where you have small bits of code that you're trying to deploy as quickly as possible, so that you can link services together. Okay, this idea of being serviceful. Definitely lots of solutions. I talked about Lambda, Google Cloud Functions. There's another solution from IBM OpenWhisk that's available. Cubeless, what do we have? We are Kubernetes-native. We support Python, Node.js. I'm just trying to speed up because I feel like I'm super slow, and then I want to get in the demo. We have functions that can be triggered by HTTP calls or events. We have integrations with Prometheus for the monitoring, and we have a plugin that's brand new from the Serverless framework. Serverless framework, it's serverless.com. It's the leading solution to deploy serverless application. It's a wrapper on top of Lambda and Google Cloud Function and Azure and OpenWhisk. Okay, it's a wrapper. It's not a solution that implements itself serverless. It's more of a wrapper to deploy those Lambdas. So what happens with Cubeless? I'm going to show you now everything. We're going to go in demo mode. And how do you deploy a function? You say Kubeless function deploy, name of the function. You specify how the function is triggered. So here it's an example with an HTTP trigger. You specify the runtime, Python 2.7. We are working on supporting Python 3.4, maybe 3.6, we'll see. And then we have Node.js 6, currently 6.10, but then I think the latest is 6.11. And then you specify your file, and then the dependencies, okay? The magic beneath all of this is that we extend the Kubernetes API with third-party resource. That's what I mentioned before. Third-party resource, it's something that's changing in Kubernetes. It's now being renamed custom resource definition, and it's becoming better. So many people were using third-party resources that we had to fix a lot of issues, or other people had to fix a lot of issues. I didn't do it. And they've been renamed custom resource definition. And basically, Cubeless is a controller written in Golang that runs inside your Kubernetes cluster, watches the API endpoint for functions, and then creates deployment when a function is created. The functions are injected into Kubernetes pods. The functions are stored in config maps. And then we have the scaling through the Kubernetes scaling of the deployments. And we do all the network routing via ingress rules. It's still in development. It's coming up. The PR is in, and we're going to have by default ingress support. And then the CLI, what does the CLI do? The Kubeless CLI. The Kubeless CLI just talks to the API server. So Kubeless is not an additional API server. We didn't have to write our own API server. We actually extended the Kubernetes API server and we talk to it directly. The big thing, the big announcement is that now we have a serverless plugin, which is really the leading system out there, and with only 4 providers supported. Amazon Lambda, Google Cloud Function, Azure Function, and OpenWhisk. And now Cubeless is supported as a first citizen provider. We're not in the documentation, but our plugin is upstream in github.com/serverless/serverless-Kubeless. Yeah, it's a mouthful. So I'll show you how to do it and what it brings you. Demo. A lot of talking. So we finished to create our cluster here. Clusters list. What do we have? G-Cloud container list. You see that I have the foobar that I just created before and the one before the webinar that have been created. And when I say kubectl get nodes, you'll see that I'm on the foobar 1. Perfect. So if you've never seen Kubernetes, that's Kubernetes for you. The first command, you see that I'm on GKE and it's running the version Kubernetes v164. 170 should come out soon. Something must be going on, but 170 should be out really, really soon. So now I want to use the cluster that I created and prepared, for the demo, because there are things that we need to switch. So I'm going to do something here, which is kubectl config view. Just to take this name here, which is the name of my context. So I'm going to switch the context, config, use context. I'm going to switch the context here. Perfect. Because what that means, I'm going to clear this and then show you all the pods that are running in my cluster. Because you could have multiple clusters available to you, on GKE, on-prem, on AWS. You could have your Minikube, and each of these clusters has an API server with some credentials. It gives you basically an endpoint. And with the kube control CLI on your laptop, you can switch between all those endpoints by doing what I just did, which is to switch context. Okay? So I say, hey, use Minikube. Boom. It's talking locally. I'm doing all my cooking locally. And then I say, hey, use context, my production cluster on GKE. Boom. Now I'm targeting my production cluster, and I need to be much more careful. Okay? So here, what did I do? I'm on a GKE cluster. If I show it to you with the get nodes, it's a GKE cluster created by default in Europe, v164, created 7 hours ago. And then you see here the pods. I have lots of pods that are running. Okay. The first thing that you notice are those kube system pods. They are the default pods or containers that are running when you create a cluster on GKE. You automatically get the dashboard running. You get an ingress load balancer. You get DNS running. You get Hipster running for the resource monitoring. And you get the FreeND pods running for logging. Okay? You see that in my default namespace, I have 2 things running. I'll mention. We'll get back to it. Then you see that I have a Cubeless namespace. Okay? So I created a Cubeless namespace, and then in that Cubeless namespace, I have my Cubeless controller. This is this Golang-based controller that does all the Cubeless smarts. You see that I also have a UI. I'm going to show you what that is. It's the UI for Cubeless. Still very early, but it's already quite interesting. And then you see that we have this Kafka and then this Zoo here, which is Zookeeper. So we have a basic development level configuration of a Kafka cluster. Okay, I said development because we don't have nice persistency backing up the Kafka logs and the Zookeeper data and things like this. There is no persistency at that level, but it's a Kafka and Zookeeper deployment using Kubernetes stateful sets, and all of this gets created from scratch. How can I, if I show you here Cubeless on GitHub, you go to a release, and I just built the release yesterday. You see that here, create namespace Cubeless, and then you just curl the manifest and run it through kubectl. This is going to launch the Kubeless controller and then the Zookeeper stuff. What we decided to do is that our release, of course has the CLI, but our release also has the Kubernetes manifest to deploy it. Okay, so that we think that's quite nice. And then you see that we have Prometheus running. Okay, so we'll see what happens there. So now you have the CLI, you do Kubeless function ls, and you have nothing running. If you do function, you see all the functions that are available, all the commands that are available. You can call a function, you can delete, deploy, of course, describe, list them, and things like this. Let me just show you okay, I have the proxy running. Okay. So now, how does this work exactly? Is that if I curl, oh no, 8080. Let's curl. I have a proxy running to talk to the Kubernetes API server. I'm going to curl localhost 8080. That way, it allows me not to have to worry about the credentials because the proxy is running. And here, look at the endpoint. Those of you on the call who are familiar with Kubernetes, you know what those are. Those are all the different API groups that you have. So, for example, deployments are in API extension v1 beta 1. Cron jobs are in API batch v2 alpha 1. Those are API groups. And then you see here something that you've never seen. APIs k8s.io/v1. This is what we created to hold our functions. This is our third-party resource. When I now curl APIs k8s.io v1, I see that it has one kind, which is function. So now we extended the Kubernetes API to be aware of function. This is the core, this is the main difference with all the other systems like OpenWhisk and Fission and FAS from Docker. Okay, we extend the Kubernetes API. We don't want to have to reinvent the wheel. We reuse all of it. Okay. Now let's go into where do we go? Okay, perfect. Let's go here. I'm going to deploy a function. If you take the code, we have an easy make file. I'm going to do a basic function, post Python. So if you look at what this function does here, it does Kubeless function deploy, name of the function. It's going to be a function triggered by an HTTP call. It's a Python function. You have the handler, and then the function comes from this file. So if we cat this file, okay, we'll see that it's a 3-line Python script that just prints the JSON of the object being passed and then returns it. Okay. So my makefile allows me to kind of cheat and have those easy calls. Okay. So look, I called it twice. The first time here I call it curl. I pass the hello world JSON to this path. Okay. The reason why I have this path is because I'm running a Kubernetes proxy, so I can reach my Kubernetes service over localhost. But I am talking to my GKE cluster. Okay. And notice where I'm reaching the function. I'm reaching the function on API v1 proxy namespace default service. It returns hello world, and then I call it again with foobar, and it returns foobar. Okay, perfect. Now let's look at the pods. Aha, I have a pod post Python. So when I did the Cubeless function deploy, I ended up with a pod running, and if I do a get deployment, I have a post Python deployment, and if I do a get service, I have a post Python service. Okay, we need to switch that. It created a node port. We need to change that. So you see, when we created the function with Kubeless function deploy, it created a third-party resource object called function in that API group. The controller that's running detected that new object, and then that's the smart that's in the controller. It created a deployment for that function, and then it wrapped it into a service. And now we see Kubeless function ls, which is, corresponds to the function we started. It gets a little bit interesting if you want to dig into the detail, which is that the code is actually stored in a config map. So you see the post Python config map, and if we do post Python -o YAML, and I hope that you guys know Kubernetes, because otherwise we're going straight into some details here. But I think that's what's interesting. So you see the API version. And here you see the code. Here is the code for the function stored in the metadata. Okay. Now let's do another example, which is a event trigger. Okay. So I was talking about service full. Like you want to use functions to tie services together. So what I did before, I deployed Minio, the object store, using Helm, the package manager for Kubernetes. So if I do Helm ls, I see that I have Minio running. If I go back to my, let's not go back. If I do a get pods, you see that you saw earlier that I had a Minio pod running. Okay, so I'm running Minio. What does that mean? It means that you guys should be able, well, actually, no, I didn't give you the keys. But pay attention to the URL. You see that this IP, it's a public IP on the Google network. You can actually hit that one. 104.199.74.234.9000. You can hit that, and the key is foobar, and the secret key is foobar foo. Okay, key is foobar, secret key foobar foo. And then this is an S3 clone, and I configured it so that when an object is being dumped in there, it sends an object to the Kafka that by default runs with Cubeless. So every time I stick a file in there, this is going to send an object onto my Kafka broker. Okay? So what I'm going to do now is I'm going to launch this function, Kubeless function deploy Slack. You see that now it's triggered on a topic. It's triggered on a topic, and we have a little convenience wrapper with Kubeless. So if you do Kubeless topic ls, you can list the topic that are on your Kafka subsystem. So you see that I have an S3 topic that's running. I'm going to deploy this function. This function is going to listen for messages on that topic, and then it will trigger. What will it trigger? It will do all of this. And if we look at the function, it says if the context, which contains an event type, is of type S3 object created put, which is something that's generated by Minio, then do API call chat blah blah blah. And this is how you publish a message to Slack using in Python. How can I talk to Slack? Is because I leverage Kubernetes secrets. So get secrets, I actually stored my Slack token into a Kubernetes secret. Okay? And my function reads my secret. Yeah, it's amazing. So let's deploy it. Let's do make Slack. Boom. Kubeless function ls. And now we have two functions. We have the post Python that we launched before, and now we have this one. Let's look at what's happening underneath. And we see that now get pods, we have the a Slack pod running. There is a Slack service, there is a Slack deployment, and then there is a Slack pod automatically created by Kubeless. Let's upload a file in that bucket, cookie.py. Okay. And then, see? Did you see the little Slack notification at the top right? Skipbox, but an object called cookie was uploaded. Okay? Just now, 6:56. And if we do another one, okay, I don't want to make it too big. Up, hey, up, here you go, another Slack notification. So here, I managed to combine two services. I combine a, let's call it a non-prem S3 clone with Minio that has been configured and sends image to the Kafka of the Kafka setup of Cubeless. And my function calls another service, Slack, and publishes a notification automatically. So this is this idea of service full. Okay. So what did we do? We did an event trigger. Ah, it's already 56. Okay, it's a long time. The serverless plugin. I just show you how to use the serverless plugin. This is coming up. I'm now using just a version that's not upstream yet. I mean the PR are not merged. So what you can do is that you can say serverless create a template of type Kubeless Node.js. So you want to create a Node.js application in the path barfoo. Okay, so serverless is this really serverless. It's this serverless framework that has tons of users and followers. And now we have a Kubeless plugin. So I go to my barfoo and I have the basic skeleton scaffolding for my function. I have an example Node.js function. I have a package.json that's needed. And then I have the serverless.yaml. That's one bit that's interesting. There is, since serverless is becoming the de facto standards to deploy apps, what we wanted to do with Cubeless is have a strong plugin so that we can start standardizing on this type of metadata to define a function. Okay? A little bit advanced, but I hope you follow me. You define a service name, you have the provider, so now you see that you have provider name Cubeless. If you use Google Cloud Functions, that would be provider name Google. Okay? Specify our plugin, and then you specify the function. Okay? Now, I need to do an npm install, so I don't wanna show you this. I'm just going to, well, actually, let's do it here. Then when you've done things, you just do a serverless deploy to launch the function. Packaging service, blah, blah. And we wait a little bit. Serverless is Node.js application. It's damn slow. No, okay, I shouldn't say this. It's a bit slow. I don't know why. It feels slow to me. It shouldn't be taking that long. So you can do serverless deploy, you can do serverless info, you can do serverless remove, you can remove functions. Here you go. So now if we do a Kubeless function ls, you'll see that, oof, oh yeah, that's because I know why. I filed a bug for this. So now you see that I've deployed a third function, capitalized, and I've deployed that function using the serverless framework. It's been deployed on my Kubernetes cluster. It's managed by Cubeless, okay, and you see it's available here with the function ls. I did file an issue for this, like what's up with those dependencies here. We're going to fix that. You want to remove things, serverless remove right here in the same directory. It's going to kill it. Okay, and then function delete Slack, function delete post Python, Cubeless, function ls, and we're back to square one. I shouldn't have done that because I didn't show you the UI, but I'm running out of time. This is the UI. I shouldn't have deleted the functions because we would have seen them right there. And then the Prometheus stuff. Okay. All our runtime, when I created the functions, we instrumented all the runtime, so we have the information. Here you go. So you see, we've instrumented all the runtime. So when you create a function, you automatically have all the monitoring, the number of function calls, the number of failures, things like this. And here at the bottom, you see function, Slack function, post Python. If I go into targets, well, don't pay attention to the ones that are, oh yeah, but we're not, yeah, they're gone already. They're gone already. But hopefully you saw it with the graphs here, that you have the graph of the function. So integration with Prometheus. This is a great webinar. Okay, stay with me. Let's do the roadmap, and then we're done, I promise. So the roadmap, we have event triggers for Node.js applications that are coming up. It's under testing. The PR is in the system. We have ingress support via the CLI. What does that mean? Is that we'll be able to say Cubeless ingress create for a function, so that the functions that we want to expose via an ingress resource for Kubernetes, like public-facing functions, we'll be able to, create those ingress extremely quickly. In bold, we have the tough questions. Additional runtimes. That's a big request from people. They want Java. They want Golang. Some people even get confused, I think, with the spectrum, the PaaS spectrum that I was mentioning. Some people, they want to run just a binary, or they want to run a Docker image, or they want to run a shell script. And now, you start thinking, well, hold on. If you're just trying to run a binary or a Docker image, this is actually just, go straight to Kubernetes. Why do you want to use Cubeless? So I think we're going to see lots of discussions about where are the boundaries of all those FAS type system. We're going to build a pipeline to be able to easily handle dependencies. People are asking for support of things like nats.io instead of Kafka. And then we're going to add schedule functions using Kubernetes cron jobs. We're going to do a Visual Studio Code plugin, improved UI, additional metadata in the serverless plugin, support for zip files. And then we have a function repository, very much like we got involved with the charts, and we're writing Kubernetes charts. We're going to develop a repository of functions, so people can browse that repository of functions, and they can start building serviceful applications. Yes. Reach me by email, sebgoa@bitnami.com. Reach me on Twitter @sebgoa. We have great documentation to get started on GKE. Check it out. So there is the official documentation, cloud.google, but on docs.bitnami.com/Kubernetes, we have lots of very good documentation. Okay. Sorry, I run late, but I'm excited. It's a long subject. Q&A, it's going to be probably too late for Q&A. Let's see what we say.
Hi, Seb. That was a great webinar. We just have a couple questions that I think we can get through. So one of the questions was, how can I use serverless how can I use it with Node.js, MongoDB, CRUD functions?
So Cubeless supports Node.js runtime, so you can create Node.js functions. MongoDB, I'm not sure what the question means, but you can. We're developing some pipelines in that repo of function that I mentioned, where we have an OCR pipeline, optical character recognition, and we have a function that stores data into Mongo. Okay, so you can do that, but there is no direct connections with the Google Cloud Functions. The CLI of Cubeless looks very much like Google Cloud Functions, but there is no connections between the two per se.
Okay, and then the last question is Cubeless still a proof of concept?
Depends what you depends what you call a proof of concept. No, it's definitely something that Bitnami is going to push. Actively. We are developing it actively. It's already very robust. We got delayed a little bit because of the controller loop. We wanted to have a really strong controller loop, and we fixed all the issues that we had early on. So it's not a POC anymore. You can use it in production you can use it in your production Kubernetes cluster and then start deploying functions. So much more than a POC.
Great. Okay, well, I think that's all the time that we have today. I just want to thank everybody again for joining us today, and thank you, Seb, for speaking today.
Thank you, everyone. Bye-bye.
Bye.